Recording this for the folks taking AP US. These are your tests that you took Monday. I'm not going to go through this in class today. Instead, I'll post all the solutions. Grayson. And I'll give you the distribution with the raw scores. There's probably going to be, where's Tim? He's not here, he is. Jacob, Annie, James, Sam, Isabel. I think there's two of them there. Mary Beth. Mary Beth. Alex. Wes. Veronica. Perfect paper. Iggy, not here. Alan, almost. Aaron, not here. Elise, the only person that had more than a perfect paper. Ryan, Cade, David, Julia, Ian, Autumn, Yang, Lucas, Iggy, not here. Everybody got one? Here's the raw score distribution, just so you can see where you fall with respect to everyone else. When I counted the points, there were 54 points, 54 total points. If you do the straight percentage, this would be 90%. This would be 80%. This would be 70%. Generally, when we put curves on these things, we try to keep the A's and the B's pretty firm and then sort of slide the C, D, F line down a little bit, depending on the distribution. Okay, so this is just this class. We've got to put Mr. Melson's class on here as well to try to figure out the total distribution, but just to sort of show how you fall. And good on Elise, she's the only one that had +1. So, you know, I don't know what to make of that. Again, I don't want to make or spend a lot of class time going over all these questions. I am going to do a complete test discussion and have that posted so you can look at it. If you've got some particular, I got to know today, see me after school, and maybe I marked something wrong that should be marked right. Okay. The one note on the second page, problem 6, 7, 8. If you got either blank in part A wrong, that's wrong. So for number 6A, you had to say 1 and 0. In 6B, if you got either part wrong, it's wrong. You had to say 2 and 1. And in 6C, if you got either part wrong, right, either the first blank or the second blank, it's wrong. So you had to get them both right. There were no half points awarded. So you had to say 1 and 0 for 6C. Okay? Yes, ma'am. Oh, yeah, absolutely. Okay. Soon. Gotta go. Okay. Today we're supposed to be doing section 10.6 in your book. 10.6 which is conic sections in polar coordinates. I do want to make one change to what the textbook does. If you look at the equations they give you, this is page 679. They're using P, Veronica, thanks. They're using P for the distance from the pole to the directrix, the distance P, and I don't want to use that. I'm using P for parabolas, right, the focal distance for parabolas. So in all the material that I'm going to give you and the practice questions on the test, I'm using the letter D. D as the distance from the pole to the directrix. Distance from the pole to the directrix. Now, will you have to memorize these formulas? The answer is no. I'll give them to you. They list them all on the last page here somewhere. Okay, so if you go to page 681, no, 680. Yeah, they have all these equations listed here, polar equations and conics. You don't have to remember any of that. How about the stuff on the bottom? If E is 1, the conic is a parabola. You think you got to know that? Yeah, you got to know that. If E is less than 1, an ellipse, you think you got to know that? Yeah. So you got to know that stuff, right? And that information about eccentricity you did long ago when we did this river and well problem. I put that back on your class page. If you've lost it, couldn't find it, you can go back and redo it again. This ratio of from the point to the focus and from the point to the directrix, that's that eccentricity. So yeah, if the eccentricity is less than 1, you have an ellipse. If the eccentricity is bigger than 1, you have a hyperbola. If the eccentricity is 1, all this stuff down here. Okay, so you have access to that. I would study that with the textbook. Okay, so that's what we're going to mess with today. Conic sections in polar coordinates. There are some sample questions, and again, you might want to just look at your sample test questions. We looked at a lot of these yesterday, but these following 3 problems, I give you the equation. I'm using D instead of P. Determine whether it's a parabola, an ellipse, or a hyperbola. Find the eccentricity, and for a bonus point, where's the directrix? Okay, so we're going to work through these 3 today. The 3 problems similar to that. It's not a long section. It's a pretty short section to do. And I do know we've got a couple of people out today taking the test, the AP test. So hopefully we'll be able to knock this out fairly quickly. Before I do that, though, I want you to do a warm-up problem. This is, again, akin to what we did yesterday. This is a conic, and we're in rectangular coordinates. So no polar stuff here, just plain old XY. Here's the equation. 16x squared plus 25y squared. I rigged this to make it nice. Minus 96x minus 256 is equal to 0. And my first question to you is, what kind of conic is it? Is it a line? No, we know it's not a line because I see squared terms. Is it a parabola? Parabolas only have 1 square term, right? This has 2 squared, not a parabola. Is it a circle? Not a circle. Why not? Not the same number, right? 16 and 25 are different. Now, they are the same sign. I don't see a minus in here, so it's not a hyperbola. This has to be an ellipse. Okay, so this is an ellipse. And so my task for you is get it in graphing form. Go ahead and complete the square, get it in graphing form, and you should be able to draw a picture. This is a nice one to draw. A, B, and C all work out to be integers. There's no crazy irrationals or fractions in it. So see if you can go and get that so it looks like x minus h squared. I'll even tell you this. This is an ellipse that opens that way, or that is a horizontal major axis. So a squared here, And y minus k squared over b squared is 1. Get it in that form so you can draw a picture. Go ahead and complete the square in x. You don't have to complete the square in y. That's already done for you. Just like yesterday, you start this way. Don't forget to leave a gap. And then go ahead and check your constant. And complete the square in x, factor out the 16. Put in the right number, add it to both sides, and you're just about done at that stage. This is your graphing form or your standard form for your ellipse. Your task is to get it in that form. Find the center, length of the major axis, length of the minor axis, the focal distance, the two foci, the vertices, all that stuff. Okay? Relatively straightforward problem, I trust. Take the 16 out. So you have x squared minus 6x, leave a gap, make sure you put a number in there. All right, this one's already, there is no need to complete the square here. This is a perfect square, so just 25y squared, 256 plus how much? It's gross, whatever it is. It's not 304. It's gross. I told you it was gross, 144. This is plus 9. Right? 16 times 9 is 144. Remember, half of negative 6 is negative 3. Negative 3 squared is 9. You complete the square. And then by adding 9, you've really added 144, so add that to both sides. X minus 3 squared, here's 25y squared, that's 400. Now, that to get to there is not that terribly difficult. You had to do two things. You had to take out the 16, and you had to complete the square with x squared minus 6x. And hopefully that is something that everybody can do in a pre-calculus class. Once you get to this, you've got to make it look like that to get it in graphing form. The key, I think, is to realize the right side of the equation has to be 1. It can't be 400. It has to be 1. So what do I do to both sides of this? Yeah, just divide by 400. That forces that to be 1. Of course, you got to divide this by 400. And lo and behold, 25 400ths reduces very nicely. You divide this by 400, and 16 400ths reduces very nicely. So you get it in a nice standard form, x minus 3 squared over 25, and then plus y squared over 16 is equal to 1. Okay, so there's your standard form or your graphing form, and you can draw a picture. You find the center point, 3, 0, right? Go 5 in the x direction, left and right. Go 4 in the y direction, left and right, etc. Okay? Make sure you can do a problem like that this weekend. One other thing that might be sort of intriguing, let me go back to here, and let's say I just gave you this, and without any other work, so all this other work is sort of gone, I ask you to find the x and the y intercepts. Okay, so that's actually a much easier problem than doing all the stuff we did below. See if you can find the x intercepts pretty quickly on this equation. Okay, x intercepts for that equation. See if you can do that. Remember how to find x-intercepts. Just make y 0. That goes away. And then solve that equation. You'll get two numbers. They're nice integers. See if you can do that. Once you find the two x-intercepts, they should be negative 2 and 8. Right? You should get negative 2 and 8 out of that, I hope. And then find the two y-intercepts. And both of those are relatively I think, straightforward problems, just solving simple quadratic equation. And you can solve quadratic equations lots of ways. You could use your calculator, you could factor it, you could use the quadratic formula, you can complete the square. I don't really care how you do it. Solving quadratic equations, four ways of doing it. So once you get the quadratic equation, any way you want to solve it, if I give you a calculator available, you can solve it on your calculator. Okay? So, x-intercepts make y 0. 16x squared minus 96x minus 256 is equal to 0. Right? So you could do that on your calculator if you like. If you're factoring, it would probably make sense to get rid of the factors of 16. And so you have x squared minus 6x, and this is minus 8, is it? 16 minus 16 is 0. Okay, and then that factors fairly nicely. I think the factors of 16 are what, 2 and 8? Yeah. So you could break that up as x minus 8. X plus 2 is 0, so x is 8 or negative 2. So you can get those x-intercepts pretty quickly. Don't lose the skill of solving equations on your calculator. There will be a section on the exam where I'm going to give you 4 or 5 equations that cannot be solved by hand, that you have to solve them on your calculator. So I know we're not to exam review yet, but if I said solve that equation on your calculator, know how to do that. Dump the equation in just as it stands, 16x squared minus 96x minus 256. Okay, and then what are you looking for? Where it's equal to 0, where it hits the axis. So you just look at a picture of it, zoom 6, and it's a weird looking parabola. This is a parabola, right? Because there's one x squared term there. And it hits the axis in a couple spots. And you can find those spots, you can find those x-intercepts by using the 0 utility. Second calc, that 0 option tells you, second calc 0. Okay, so this one looks like it's near negative 2. Actually, no, it is negative 2, but say we didn't know the answer. Left bound, negative 3, and then negative 1, and I guess, and it says negative 2 there. So I got an answer. And the same thing on the other side. It looks like it's around 8-ish. So, you know, between 5 and 10, you could do that. Okay? So finding zeros on your calculator doesn't take more than, 15, 20 seconds if you know how to use your calculator. Okay? How about y-intercepts? Y-intercepts. Anybody get an answer for that one yet? It's actually an easier problem. Right. Okay, so because there's only y's there, to find the y-intercepts, you just make x 0, which takes this out, and you get 25y squared is 256, or y squared is 256 over 25, or y is plus or minus the square root of 256 over 5. Is 256 a perfect square? Okay, so what is that? 16/5. Okay. Comments, questions on that? Now, let's suppose you didn't know how to do this. You're brain dead because it's the end of the exam and you've been, these poor people that take the AP test, like they think for 3 hours and they can't think after that, so they have to go home. It sounds a little weird. It's like That's how the Chinese are going to invade the United States, right? They're going to make everybody think for 3 hours, and then you can't think anymore. Let's go home. Sorry. Okay. So solve this equation on your calculator. You can solve any equation on your calculator. Solve that on your calculator. Okay? 25y squared equals 256. Now, the fact that there's a y squared should not bother you. Remember, these variables can be anything. This could be 25 theta squared is 256, or 25a squared is 256. You're going to solve them all the same way. You're going to put them in as x. Right? So you're going to punch it right in here as 25x squared. Now, minus 256, right, because we want to make it equal to 0. You look at the picture, zoom 6, there it is, and it looks like there's two solutions. So you find those two solutions. This one looks like it's between, I don't know, -4 and -2, somewhere in there. So chase that down between -4 on the left and -2 on the right. And there, oops. Let's try it again, Joe. 1, 2, 3, 4. Yeah, between -4 and -2. What did I hit in? 0, -4, -2. There, okay? And it gives us the answer, -3.2. Okay. Which we got, -16 fifths, right? 16 fifths, 3.2. Okay, and you get the other one the same way. So yeah, you can solve any equation on your calculator. And now, even though both of these you could do by hand, note that there are equations that you cannot solve by hand. So again, a little sneak preview of the exam. If I gave you the cosine of x is equal to x, solve that equation, it's impossible to do it by hand. See if you can come up with an answer. Cosine of x is x. If you have an answer, flag a hand up. I'll just see how long it takes for somebody to do. It should take about 15 seconds. Anybody got one? I'm close. Okay, what's your number? Yeah. Say it again. Point. Okay, so unfortunately that's wrong. I would have to mark that wrong. So sad. That's not 1. That's the cosine of 1 is not 1, so that's wrong. Anybody got another one? 739. Okay, so that's correct. Okay, so you might have noticed yesterday I made all my little darlings in AP Calculus come down to the cafeteria, and I bribed them. I said, show me your calculator in radian mode, and I will give you a donut. You're in radian mode, you get the right answer. You're in degree mode, you got the wrong answer, right? Okay, so when dealing with trig functions like this, you have to make sure you're in radian mode, otherwise you get the wrong answer. And by the by, if this were a question on the exam, you can bet your sweet bippy that I'm going to give that as one of the choices, and this will also be one of the choices, and this one is right and this one is wrong, because somebody's going to walk into the test in degree mode and they're going to get it wrong. Cosine of x, take away x, zoom 6, there you go, it hits right there, and you can find that 0 pretty quickly. Again, this shouldn't take a lot of time. You guys can text way, way faster than I can, but you should be able to hit buttons on your calculator just as fast as you text. There's the answer, 739. Okay? Well, back to the topic at hand. We're talking about section 10.6, the conic sections in polar coordinates. And we're going to be very, very special case here. The only conic sections we're going to deal with are ones that have a focus a focus point at the pole. Okay, so imagine your good old polar coordinate grid where you have all these little circles and these radial lines zipping away at various angles. And what we're going to consider are parabolas, ellipses, hyperbolas, and maybe even circles if you like. There's not really a focus for a circle, but I'll talk about it, where the focus point is at the pole. So let's pretend we had an ellipse, and the ellipse might look like this. And one of the focus points will be right there at the pole. Now, there's another focus point out here somewhere, right, because the ellipses have two focus points. But we're going to consider just the one focus at the pole. If this were a parabola, and go back to your river and well problem, if that's the well, you can imagine a parabola looking like this. And again, there's going to be a focus point, the well, at the pole. Hyperbola is sort of the same way. You could have a hyperbola that looks like this, and one focus point is there, and there's another focus point over here. But we're just going to consider one of the two foci at the pole, the focus point at the pole. Okay, now for all of these, they have a very special form. And let me just sort of give you the general idea. R is equal to E times D. This is going to be a 1, always a 1. This could be plus or minus. Some of them have pluses, some of them have minuses. And this will be E. E is the eccentricity. I'll note that. E is eccentricity. E is not equal to 2.7, 18, 28, etc. That's not the E we're talking about. We're not talking the natural base. We're talking, it's unfortunate we have the same letter. E is a number on our calculator. There, E. Right. But that's not the E we're talking about. We're not talking that E. We're talking the eccentricity of the conic section. So in this formulation, E is eccentricity. And the D number here is the distance from the pole to the directrix. From the pole to the directrix. And following the E here, you can have either the sine or the cosine of theta. Okay, so let me give an example for starters. We're going to graph it on the calculator, we're going to graph it by hand, and then we're going to actually graph it using all the stuff we know about parabolas. Okay, so here's first example I've got somewhere. Okay, so R is equal to 6 over 1 minus the cosine of theta. And so here's an equation that I've sort of ginned up to use as our first example. And I claim that that is a conic section. This number 6 is E times D. There is a 1 in this slot. You see a minus sign. I said it could be plus or minus. You see, there's supposed to be a number in front of the sine or cosine. Was there? 1. So we're multiplying by 1. Okay, so that tells me my eccentricity is 1. By the way, what kind of conic section will this be? So it will be a parabola. It has to be because the eccentricity is 1. Let's try graphing it on the calculator to verify that it actually comes out to be a parabola. Grab your calculator, put it in polar mode now. You're not going to be in function mode, you're going to be in polar mode. Make sure you're dealing with radians. If you're coming out of physics class, you're probably in degrees. Make sure you're in radians, polar mode. Go to R equals and type in 6 divided by 1 minus the cosine of theta and verify that you get a parabola. 1 minus the cosine of theta, and sure enough, or 6 divided by, 6 divided by 1 minus cosine of theta. Okay? And sure enough, we see a parabola. And you can sort of imagine the focus point right here. This is the well, if you will. And the directrix is going to be over here. Remember when we did these guys in class with the river and the well idea? We had the directrix, we had the focus, and the parabola fit in like this. Right? Like that? Okay, and that's what you're seeing on the calculator. Now, what the calculator doesn't show is where's the directrix. The directrix is this line over here. It's to the left side of the pole. This is the pole. That's the focus. And this is the directrix. So the question is, where's the directrix? Could you actually get the directrix in on your calculator? The answer is, yeah, you can. Let's go back to the equation I have here. Remember, this number on top is E times D. So what is D for this problem? D is 6. D is 6. How do I know that? Well, because I know E is 1. This is 1 times D, so D has got to be 6. What that means is the directrix is 6 units away from the pole. So if we tried to, if we were drawing a sketch by hand, we would go, okay, I know my parabola looks like this. And this is 3 units, 1, 2, 3, and the directrix is 6, 1, 2, 3. So here's the directrix over here. This is like, if we were in XY world, this is just X is negative 6. X is negative, it's 6 units away, 6 units away from the pole, from the focus. Okay? Now, and again, I suppose we could show that pretty, I can't type in X is equal to. How do I do X is equal to negative 6 on my calculator? I got to do R equals, right? How do I do that? Anybody? X is negative 6. How do I type that in for R? X is negative 6. I want R is equal to? Negative 6. Say again. What was for X? X was R cosine theta? R cosine theta is negative 6. R is negative 6 divided by cosine theta, right? Okay, so let's do that. Do negative 6 divided by cosine of theta. Yeah, you got to remember your conversions. Okay, so that now shows me my directrix, right? So I have the conic, the focus is at the pole, the directrix is over here to the left side of the pole, and it happens to be the line X is negative 6. It's 6 units away, and I know that because that says 6. Is that right? Now, let's play a game where we didn't have the calculator available. So now this is out of the picture, and I want to try to come up with the graph of this by hand. And you go, oh, I don't want to do that. Going back to Algebra 1, one of the things that you should have gotten used to early on is plotting points. So I'm going to plot some points. I'm going to get a little chart going here, R's and thetas. And I've got to pick certain numbers to put in here for theta, and that will calculate R. So give me a good theta number to plug in, something that I might know. I could do 45 degrees, or I could do pi over 2, pi, standard angles. Let's try pi over 2 for starters. If you put pi over 2 right there, what does R work out to be? R works out to be, let's see, R is going to be 6 divided by 1 minus the cosine of pi over 2. Now, you're supposed to know what the cosine of pi over 2 is. If you don't know that, I should probably give you a 0, but that would be 0. The cosine of pi over 2 is 0. All right, so this works out to be 6. Okay, so now I have a point. Yeehaw, I've just found one point on my parabola. The r is 6 and the theta is pi over 2. So if I were drawing this by hand, I would go, okay, I've got my little polar grid, and you can go find one of those if you want. But in the direction pi over 2, you're going to go 6 units. 1, 2, 3, 4, 5, 6. You'll be on the 6th ring up here somewhere. And there's a point on the parabola. Well, that doesn't do a lot for me. So maybe somebody give me another angle I can use. Just pick a standard angle that might be easy to calculate. Okay, we could try 0. That's not a bad angle to try. How about pi? How about 3 pi over 2? I mean, let's just do the quadrantal angles. That are pretty easy to do, right? Okay, so if you put 0 in there, now r is going to be 6 divided by 1 minus the cosine of 0. And the cosine of 0 is? Cosine of 0? It's 1. What happens? You can't do it. Okay, it's impossible. So this is undefined. There is no dot when theta is 0 because it says 6 divided by 0, which you can't do. Okay, so in this direction anyway, if we're going this direction, there is never a point on that axis anywhere ever. Right? Can't do it. Okay, well, let's try pi. If you put pi in, now you have this. You're putting pi in for theta. Right? Pi in for theta. And what does r work out to be? 3. Right? So this is 1 minus the cosine of pi, and the cosine of pi is -1. That's the left side of the circle. So 1 minus 1 is 2. 1 minus minus 1 is 2. So 6 over 2, which is 3. Okay, so that tells me in polar coordinates, if I'm facing west, I just go 3 units. 1, 2, 3. Okay, so there's a dot. Remember, I'm getting this parabola. This is, we've already looked at the picture of it. There's the picture, right? So if you look at this point on the y-axis, it's 6 units up. That was the 6 pi over 2, right? And if you look at the point on the x-axis, it's like 3 units to the left. It's over at -3. That's this one, right? 3 pi. We suspect there's another one down here. If I plug in 3 pi over 2, let's see what happens. Plug in 3 pi over 2. So you get 1 minus the cosine of 3 pi over 2. And what is the cosine of 3 pi over 2? Say again. 0, bottom of the circle. Cosine is 0. Okay, so this is 6 divided by 1, which is 6. Okay, so sure enough, here we are. We're back down 6 units away. Oops, where did I go? Where did I go? There we are, 6 units away. We'd be down here, 1, 2, 3, 4, 5, 6, like that. Okay. Now we could put other points in, but sure enough, this parabola is looking like this. This is a parabola. Okay, parabola. The directrix, it's a vertical directrix. It happens to be to the left of the pole, and this distance is d, which you can get from the equation is 6. So you just go 6 units to the left. Let me give you another example, sort of set up the same way. I've got, I'm going to use this pattern again, ED, and again, once again, I'll do minus E, and we'll leave this as cosine. This will still be a conic section. The focus will be at the pole, and the directrix will be to the left. It's going to look just like this, except it's not going to be a parabola. Okay, so let me give you the equation first, and I'm going to ask you to play with it a little bit by hand, not with your calculator, and see if you can come up with the picture. Okay, and then we'll put in the calculator and verify. So the equation I've got is R is equal to 16 divided by 5 minus 3/5 cosine of theta. So that's the question. And the first thing we've got to figure out is what kind of conic section it is. What kind of conic section it is. Sorry. It should be a 5. This should be a, let me write it down right, Joe, 3. Okay, there. Okay. Now, early on in this exercise, you should be able to tell right off the bat what the eccentricity is and therefore what kind of conic section it is. Those two questions go very, very quickly. When you're doing your practice test, it says, tell me whether it's a parabola, an ellipse, or a hyperbola. Tell me the eccentricity. Those two questions go very, very quickly. In this case, again, I'm giving you the formula. Don't have to worry about the formula. It says 1 minus E sine of theta. 1 minus 2. What's the eccentricity? 2. What kind of conic section is it? Hyperbola, right? Eccentricities. Eccentricity, 0 is a circle, 1 is a parabola, everything in here is an ellipse, this is a parabola, and everything bigger than 1 is your hyperbola. And so, yeah, if it's between 0 and 1, that's your ellipse. That has an eccentricity of 2. So I know it's a hyperbola, and I know the eccentricity. I'm done. I get those two things, and it takes 5 seconds. How about this one? It says 1 minus E. What's the eccentricity? 1. What is it? A parabola. Done. Look at this one. Now, here's the formula. You don't have to remember the formula. It says 1 plus E. Oh, that's not 1. Okay. Yeah, so in order to deal with this, you got to make that a 1. Right? So you're going to multiply. We've got 6 over 2 plus cosine theta. That's what R is. Just multiply this thing by 1/2 over 1/2. I know that sounds a little weird. It's maybe easier to say divide top and bottom by 2. But I would trust that multiplying by 1/2 over 1/2, you're multiplying by 1 so it doesn't change. And why do you do that? Well, because now it forces this thing to be a 1. Okay, so you get 3 on top, and you get 1 plus 1/2 cosine theta. Eccentricity is a half. The curve is an ellipse. Okay, so let's go back to the problem at hand. The task was, what is the eccentricity? What is the eccentricity? And then what kind of curve is it? Eccentricity is 3 over 5. 3 over 5. Okay, right, this has got to be a 1. So you multiply by 1/5, 1/5, 1/5. Okay, so this is the same as 16 over 5 divided by 1 minus 3/5 cosine. Yeah? Okay, so I know it's an ellipse. I know it's an ellipse. See if you can give me a couple of points for this. I would use these same angles. Use those angles. 0, pi over 2, pi, 3 pi over 2. Use the original equation. And no fractions in the original equation. And figure out what R is for each one of those guys. Plot the points, and lo and behold, you'll end up with an ellipse. It works really cool. And then you can try it on your calculator. Okay, so if theta is 0, the cosine of 0 is 1. So this is 16 divided by 5 minus 3 times 1, which is 8. Okay, so 8, 0 is a point. Plot it on the piece of paper. If theta is pi over 2, the cosine of pi over 2 is 0. 3 times 0 is 0, so this works out to be 16/5. You would have to plot that. If theta is pi, the cosine of pi is -1. So now we have 16 divided by 5 minus 3 times -1, which is 2, right? 2, I trust. Right? 5, take away 3. Yes, no? 5, it's 5 plus 3, which is 8. 16 divided by 8 is 2. There we are. 3 pi over 2 cosine is still 0, so you're back to 16/5. And then we go ahead and just draw a little picture. If this is our polar grid, again, I don't have the full grid here, but in that direction you go 8, 3, 4, 5, 6, 7, 8. In this direction, you go 2, 16 fifths is about 3 and a smidgen. So there and there. And here's your ellipse. Okay, have a good weekend. I should see you all in a couple weeks, if not sooner. Bye. Okay. Let me mark it up and I'll give it to you. I handed back the graded test. Where are you headed now? Okay. I'll drop it off down. Is it Mr. Butrin? Okay, I'll drop it off down there. Yes, ma'am. I'm sorry? Yes. I said there would. I got to get with Mr. Nelson. Pardon me? No, I've got them all recorded. You're good. You can keep them. Howdy.